Okay, good day learners. Nice to be teaching you once again. Forgive me, this is my first video that I'm making if I make any errors. And yeah, okay, let's get straight to it. Our first section for term 2 is geometric constructions. You should be opening this booklet here that I sent in the PDF. Here they talk about the different names of the instruments, the protractor, ruler, compass, etc. You already learned this in grade 8. Also, you've learned in grade 8 how to construct parallel and perpendicular lines, etc., etc. We will be tackling most of this in our in this video right now. Grade 9, right? This is what we're interested in. All of these topics over here is what we are going to tackle. All right, let's see our first. Okay, the first thing we've got here is how to bisect an angle. So let's get an angle. First of all, let me just okay, just 1 second. Okay, here we go. Right, so let's try and just start off by drawing an angle. Any angle. Just an angle. Right, so we've got this angle here and we need to bisect this angle. The meaning of bisect is to divide it into two equal parts. So if you have to bisect this, you open your compass to any suitable measurement, and and you draw an arc. Right, you draw an arc, then you same measurement, do not change it, you come here, you make a bit of an arc there, you come to this point here, you draw an arc as well. Now we're going to be having this point here. I hope you, let's see if you can see this red color. Okay, I'm not sure you can see that as a red color, but okay, I got a red color there. So once again, let's see what we did. All right, we opened to any suitable measurement, we drew an arc, we came to this point here, we cut an arc, we went to the other point there, we cut another arc. Now where those two intersected, we've got this point here. I take my ruler and I draw a straight line. Right, now you can see that this angle here is the same as this angle. This is called bisecting an angle. Right, so let's try and bisect a line. So if you have a line, okay, so if you've got a line, let's just draw just any measurement of a line. Okay, let's be a bit more accurate, just to prove, right? Okay, so if I draw a line that's say 7 centimeters from here to here is 7, then the halfway point should be 3.5, which is here. All right, so to bisect a line, right, now let's imagine we did not know this. You open your compass to anywhere past halfway, half a circle, come this way here, half a circle. Right, then we've got the point here and we've got another point here. You're going to draw a straight line. Can you see that it now broke this line into half? Bisect means breaking it into half. Right, okay, next up we've got the 60 degree. All right, so let's just push that off. 60 degree. Okay, to draw a 60 degree line, Now we are very used to just doing this. We use our protractor, we come there, we see 60, can you see a 60? And you would have put your dot over there and you would have constructed your line. However, in geometric constructions, we're not going to be really using that protractor. You open your compass to any suitable radius. Once again, suitable radius is something that's comfortable to work with. If it's too small like this, you can't work with it. If it's too big like that, you're going to go out of your page and it's also a bit hard to work with. So you open something that's suitable, something that's even in your notes it says about 2 centimeters is suitable. Something like this is fine. So you do like sort of a half a circle where you, can you see that? Not sure if we can really see that. Okay, right, so we draw sort of a half a circle, right? Our most important points is that we can see that it intersects here, right? Then with the same measurement, do not change your measurement. We're gonna go here, cut an arc. Can you see where it intersects there, right? So this, see, to hit this line here is a 60 degree. We just saw that with our protractor. So we now, from our constructions, we have this, sorry, can you see that? We've now constructed a 60 degree line. Once again, let's see how we do that again. We go suitable radius, draw half a circle. We come here, we just, where there's a point of intersection, we just, yeah, you can see that, we just cut there. Then that point, we just draw a line. Let's double check if this is a 60 degree line. Let's check. Perfect. Can you see the 60 degree line? Right. So to construct a 30, right? So far we constructed the 60 degree. To construct 30, it's exactly what we did for the 60, but we need to bisect this angle. Now going back to our bisecting an angle, let's see what we need to do again. We needed to open a suitable radius. There's my suitable radius. We cut an arc. We come to our first point, make an arc, go to a second point there and make an arc, right? So these arcs, I'm not sure if you can see them very clearly, but there's your point there now. So if I draw this line, let's draw this line. This should be a 30 degree line. So let's double check that. Right, so we're checking here, there we go, 30 degree line. This is a 30 degree angle, sorry, 30 degree angle, right? So I've shown you bisecting an angle, breaking any angle into two parts, bisecting a line. I showed you the 60 degree, I've shown you the 30 degree. Now let's go to the 90 degree. 90 degree can be a bit tricky. Let's just once again just start with the line. Let's just start with the line, right? So there's my line there. There's my line. So here, suitable radius. Once again, suitable radius, right? Half a circle, right? From here where it intersected, draw an arc. Then I'm not sure if you can see it, but let's this is what I want you to look at. I want you to look at, let's just break that off. I want you to look at, see this line here. This is the line that we start off with, right? This is the line we start off with. And if we continue this line, maybe let me use a blue pen. I hope you can maybe see the color here. We can't see the color. Okay, I just extended this line just to get this intersection point. Can you see? We started off with this. And then we drew half a circle, right? We extended this line until we came here. With my same suitable radius, do not change your measurement. Once you start drawing, do not change your measurement. Right? So we drew there. Once again, let's start again. We started just with this. Let me try and block up this line. We started just with this line here, right? We extended this line such that when we draw this half a circle, it intersected there. Can you see that point there? And then we came here, cut, then from here now, see these intersections here. Yes, let's just, right, so we come here, draw an arc, right, and then we now, camera crooked, okay, there we go. Then we've got this point over here, right? Now if we draw a line there, this should be 90 degrees. Let's double check. Let's just get this straight. Yes, okay, just to make sure that this is straight. Can you see this line is going this way, like that, and then like that? That needs to be on your point there. So can you see that now I'm not exactly at 0 degrees? I need to be on the line there. That's right, don't be somewhere there. This 0 needs to be on your line there. And can we see that this here is a 90 degree line? So this here is 90, this is your 90 degree line, right? So once again, you started with this line here, right? You open your suitable radius, we drew half a circle, right? We drew half a circle. We've got a, then we have these points here. Let's call it point 1, point 2. With the same suitable radius, from point 1 we cut, from point 2 we cut. So for point 1 we've made something, let's just call it point 3. Then we've also made point 4, right? From this we cut and we made point 5. Your last step, you draw that. That's your 90 degree. Now to get your 45 degree, right? So we finish off 90 degree. To get your 45 degree, you need to do all what you've done for your 90 and then bisect it and make a 45. To bisect, let's just hope that my radius didn't, suitable radius didn't change. Sometimes it changes as you move along. Let's change it up, right? Let's just make this one a little bit bigger, right? So we've got this angle. Remember to bisect now, right? Remember we've got this angle here, right? Now to bisect, we need to go to this intersection, draw an arc there, go to this intersection here and draw your arc. Then I've got this point. Maybe let's use the blue pen. I don't think so we can really see color very much in this video. Try and sort that out later. Okay, here we go. Now what we've just done is, see with these points here, let's call this point A and let's call this point B. We've done the technique of bisecting an angle. We've done the technique here, right? There's my point A, there's my point B once again. Then we made an arc. Let me just take it. We've made an arc, made an arc there, we've made an arc here, and then we have drawn our line through. Now this should be a 45 degree line. Here we go. Let me set, yeah, there we go. 40, there's 50, 41, 2, 3, 4, 5, 45 degree line. So once again, let's see what we've covered. Bisecting angle, bisecting a line, 60 degree, 30 degree. Okay, well, once again, a 30 degree is just a 60 degree, and you bisect it. You break it up into 2. 60 divided by 2 is 30. Same story with a 90. You draw this 90. Yes, 90 has a lot of points. You mostly find this in your EGD at your grade. I think it's called, I'm not sure exactly what it's called, but it's called, some schools call it TCOM, some schools call it drawing, or the part A of technology, etc. Yeah, so this is what's found there, and then we mark you accordingly. See, if we just take this protractor and if you just draw the 90 degree, you lose out. Let me show you what you lose out. You lose out 1, 2, 3, 4, 5, and drawing the line 6 marks. You lose out 6 marks. You just get maybe for drawing the line 1 out of 6, right? So yeah, so this is construction so far. Let's see what's next up on our list. Example 6 on page 30. Let's check example 6, page 130. Let's get there. Okay, I've done all this with you now. Okay, example 6, there we go. Right. Okay, construct a scalene. Right, let me just get my page there. Roll off. Okay, let's look at it now, right? Question says construct a scalene triangle with DE is equal to so much, etc. let's do this construction here, right? So let's get my page getting stuck there. Okay, just 1 second. All right, so let's see. It's telling us to construct a triangle DEF with DE is equal to 7, DF is equal to 5, and EF is equal to 8. So let's go back to the video there. All right, I just wrote that information down, right? So we need to draw this triangle. We need to construct this triangle. That's what they say, right? So let's start with DE is equal to 7. So let's let me just align this properly. Oops, sorry. Okay, I'm still new to this, so let's check now, right? Rather fold this. Okay, sorry about that. Right, let's check. DE 7. So we've got DE 7. So let's name this. We're gonna say DE. Then it tells us that DE is 7, right? D is 7, and then it tells us DF. Then, but there's no F. Okay, so F is gonna be somewhere top here. Do we agree on that? So we're gonna have a triangle looking something like this. F is gonna be somewhere here. So F is gonna be 5. So if I take my ruler now, right? 5. Let's check this. 5 can be from here to here. Let me just use my pencil because I'm gonna purposely do something incorrect. Right. So 5 could be here, right? And if my 5 is there, then this could be my triangle. Am I right? If we're gonna call this F, from here to here we said that this is 5. Then it tells us EF is 8. E to F is supposed to be 8, but we've got what is this? 2.6. It's not working out. This can't be the triangle that they're talking about. So what can we do? Let's try this again. If we do DF 5, there we go. If we do DF as 5 over there, right? Okay. Now, can you see it's a little bit away there, right? So if this is my F, then let's check if EF becomes 8 with this new F. We're looking at this F, right? I seem to have lost my eraser, but anyways, You see now it's 3 point something. So we're coming to the right thing, but how can we have one method that solves out everything? This is how we do it. we need df to be 5. Alright, so we're gonna open up our, oh, we can't see that, sorry. Okay, so we're gonna open up to 5. Let me just get there to 5. Yeah, there we go. We can do this. Can you see that? Yes, it would have touched that first F that we drew. It would have touched the second F that we drew. So we draw like half a circle or something that's suitable. I'll show you what this means just now, right? If we brand new to this. So we drew like a circle. Can you see that? We drew like a circle. So this here, the radius, I hope you realize that the radius of here is always 5. From here to here is 5. See, I did not change my compass. And so from here to here is going to be 5. Sorry. From here to here is going to be 5. Here to here is 5. Can you see that? 5, etc. So what I'm trying to say is, from here to here is 5. This entire circle from this dot to there is going to be 5. Right? So we drew the circle. Then from EF is going to be 8. So let's open till 8. Let's get to 8. Alright, so we open to 8 there. EF. Can you see where that intersected? It intersected here. So this is a point called F. So if I join all these lines, right? Let us join these lines. Right? I join that line. I join this line. Right? Can we see that we drew a triangle DEF? There's my DEF. Now DE, let's just double check our work, right? DE is 7. DE is 7. Yes, 7 centimeter. We check that. Then we got DF. There's DF there. Let us measure DF. Okay, let me just turn this here. Right, DF, we can see it is 5. Correct. So this is 5 centimeters. FE is 8. Can you see that is 8 centimeters, right? So we've got that. We drew that. let's see what the question says. Let's see what the question says. Construct that. We've constructed that, right? Measure angle D, angle E, and angle F, right? Well, let's do that. Where we are here. Okay. Angle D. Just 1 second. Yeah, angle D. So this is angle D. Sorry about that. This is angle D, right? So I get this here, and I see that it goes to 82. So this is. Let me change my pen color. I'm not sure. I think we can see 82 degrees, right? Let's measure angle E. Angle E, we've got 38. Yeah, 38, right? So here we've got 38 degrees, and if you measure this angle here, let me just get this straight. Let's check in there. This is 60, right? Can you see the 60? So we're saying that this here is 60 degrees, right? All right, so we literally measured each angle, and we've got this information up on the screen. It's not up on the board, it's on the screen nowadays. Okay, let's go back here. Okay, so we measured those angles. Then they say calculate angle D plus E plus F. What do you notice? Let's see, what do we notice? If we say angle D plus E plus F, right? D, we got the 82 degrees. Please don't forget your degrees. E, we've got 38 degrees, plus F is 60 degrees. Let's see, right? We're gonna have there. Okay, let's just put that up. We've got 82 plus 38 plus 60 is equal to 180. is equal to 180 degrees. So what did we learn here? We learned that the internal angles of a triangle add up to 180 degrees. That was one of the things they showed you. Okay, it's up there on page 1, right? Let's see, extend DF to H, DF to H, EF, EH, FE, bisect the angles. Okay, no, we're not going to do that one there now, right? Okay, let's see. Okay, that's your solutions, right? That's your solutions. Okay, I think it'll be quicker if I just show you here. No, we're not doing that. Let me just check in my notes what's our next one there. Okay, basically you're learning your exterior angles of a triangle there, right? Let's move on. Right, I've done that, right? Exercise 1, there we go. Exercise 1. Now, according to I've also sent this Excel sheet there for geometric constructions. In your workbooks, this is what I want on this, right? In your workbooks, you're going to be doing bisecting an angle and a line, right? And you're going to be doing all of these degree angles. This is in your workbook, eh? Exercise 1 and everything else is there, right? Right now we're here at exercise 1. Then after you finish all of this should be done on the 17th. I want an assignment from you which includes exercise 1 you need to give me back, and constructions of quads. We're about to get there. So far we're here, we're going to be moving down this now. So that's what I want from you. All right, this is all found on my Google Classroom. Yeah, it's there, right? So let's see what was next. Exercise 1. Let's just double check that. Exercise 1, you don't have to do all. You got A, B, D, and E. So we've got A, same thing what we just did. B, D, and E, right? Let's see what else is up next. Okay, page 132. 132, for example. 5, 7, 8. Okay, yeah, there we go, right? So next up on my notes, I've got example 7 on page 132, right? So we're looking at this here. So far, the question is, use the constructions to prove that the sum of the angles of a triangle equal to 180. Now, how can we do something like this? We already did it mathematically. Let's just get to my picture. Yeah, we already did it mathematically. We used our protractor and we sorted that there out. Now, is there a way we can do that just with our compass? We'll be learning lots of new techniques just using our compass, right? So let's see what they want us to learn here. So they want us to open up to 2 centimeters. Let's get a 2 centimeters there. Okay, so we've got our 2 centimeters there. Oh, sorry, my video wasn't on. Sorry about that. Okay, we open up a 2 centimeter. Let's just get that. Okay, that's it. Open up at 2 centimeters. They want us to draw a 2 centimeters on each angle, right? As you read through the notes, they want us to draw 2 centimeters on each of the angles there, right? So anyways, let me just draw this a bit bigger so you can see. I've got that, and now I have that. Let's see if if you can see my highlighter on this video. Yes, we can. All right, so I'm interested in these points here. You're going to see why just now, right? So anyways, I drew 2 centimeter radius arcs over there, right? I drew that, and now I think something that's a bit familiar to you. Let us just look at just a straight line. we've learned in grade 8 that the straight line is equal to 180 degrees, am I right? So if I draw with the same radius, right, we're not changing this radius here. So if I draw a line like that, do you agree that this is 180 degrees, right? So if this is 180 degrees excuse me, yeah, so this is 180 degrees. Now let's measure, see from here. Okay, let me just show you first before I start to do it. From here to here, see our angle D, we can measure from here to here. That measurement, let's just get that. I'm not used to this compass, but anyways, let's work with it. I'm used to working like this. Okay, so I got that measurement, right? I took that measurement, and let's add it. See, we start here. Let's look at this before I do anything. From here is 0 degrees. Let's say this is 0 degrees. As we move on, we go to 180, right? So let's put here. Oh, she moved a little bit. Okay, sorry. Let's just be a bit accurate with this, because if you're not accurate with this, you go off, right? Let me just redo this. Alright, so this here is our point. So what am I saying? See, from here to here was angle D. So angle D filled up of this 180 degrees. Angle D filled up from here to here. Let's call that angle D. D is from here to here. Let's see what E is. E is from here to there. So let's put that in there. Okay, so E was from here to here, right? And let's check out F. F is from here to here. There we go. So can we see F is from here to here, right? Can we now see that when we add up angle D, let's call it angle D, when you add up angle E, when you add up angle F, you land off to 180 degrees. So that's what they're showing you there in example, what is that? Example 7. Example 7 is if you can take these angles and measure them like this with this new technique that you've learned, we can prove that it is equal to excuse me, 180 degrees. What's next up? I've got example 8. Let's see what's example 8. Okay, basically that's what they showed you there, right? Oh, okay, this is a nice one. Use the constructions to prove that the exterior angle of the triangle is equal to the sum of the interior opposite angles. So this is what we know, right? We know that the whatever measurement of the angle outside here, and angle E, is equal to the sum of the interior opposite angles, meaning whatever is here is equal to this plus this, right? Now we're proving it using our compass and geometric constructions, right? So this exact thing has already been, we've been working with that example all along. Let's see, right? So if I extend this line here, if I extend this line here, there we go, we extended the line, right? So what we're saying is here, see here, this is equal to this plus this. So let's get that, right? First of all, let us, okay, let me open a smaller angle there, right? I open up a smaller angle there, right? So this should be equal to this plus this. Okay, no, okay, my mistake. You're not supposed to change your radius. My mistake there. Let's just copy this radius. Okay, so we opening here, right? We're opening here. Now I'm going to take this angle's measurement, right? This angle plus this angle. Can you see that? So our opening from here to here was angle D. We put that there. We landed off here. From here to here was angle F, right? So we proved that this was angle D, this was angle F. From here to here was angle F, F's measurement. And let's just break that up so I can show you clearly. From here to here was angle D. So this plus this one, they added up, right? Meaning this plus this gave us this, right? So we proved that. Let's get to, let's see what's next up here. Activity 1 to 4 on page 135. Let's see it. Oh, okay, yes, congruency, right? So okay, we haven't really gone to congruency of triangles and similarity, etc. But let me just check what the size. Okay, we can't recycle the same question here, right? So congruence. Okay, how I teach all my learners is that similarity is similar, but it's not the same. They are similar, but they're not the same. Congruency means that the triangles are exactly the same. So, for example, now I know that we know how excuse me. Where is this? All right. We know about our 4 conditions, right? Side, 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 side angle, angle, side angle, side, and right angle, hypotenuse, and a side, right? We learned that in grade 8. So what these activities here, from activity 1 to activity 4 is showing you, they're showing you that these triangles are exactly the same. So what they're gonna make you do here is, for time's sake now, I don't want this video to be too long. What's happening is they draw this for you, right? And they draw this for you. They ask you to draw this out. Okay, let's see. How do I see how long this video has been? It's not showing me. Okay, it's not showing me how long this video has been. Right, anyways. Okay, let's just stop this video here because I don't want the video to be too long. Yeah, let's just stop this one.